we are. See all of our faces. And just so you know, we are recording this event. So once you enjoy and you want to share with others, please feel free to do that. So good afternoon. I'm Gretchen Stewart, and thanks so much for attending today. And we really look forward to a great session. We have a few slides to kind of set the stage, but then we're really going to be talking through lots of questions, answering yours, and we have some of our own. So we're looking forward to it. So again, I'm Gretchen Stewart. I'm the Chief Data Scientist for our Intel Public Sector team. And in my role, data security is a must, as we all know, and I'm delighted to be the host and moderator for today's event. In today's session, we're going to talk about the critical needs of security, why you need to build that into your IT environment and your cloud instances from the start. As we all know, cyber attacks are moving up and down the compute stack, traveling from hardware to software, software to hardware, software to software, and that we really need to ensure that we've got that data protection. So we are looking forward to talking about the marriage of hardware and software. We've taken expertise from Intel as it relates to hardware, and partnering with Lockheed, who we have on the line with us. And then also we're delivering it through a great cloud solution by OROC. So I am joined today by Bill Giard. He's our CTO of IT transformation and part of our data center group at Intel. Bill has over 20 years of experience in designing secure enterprise architectures and developing hardened security software solutions with our key partners like Lockheed. It's all to support mission critical systems. It could be supply chain, product development, enterprise infrastructure. Prior to joining the organization, he led a software team. So very familiar with software and hardware and the right things that we need to do from a security perspective. We also have Adam Miller from Lockheed. I really am delighted that you're joining us today. Thank you, Adam. He's the Director of New Initiatives for Lockheed Martin Missile and Fire Control. He has over 35 years of experience and a broad range of roles around business development, capture, product management, engineering, research and development. And in his current role, he's working on joint development projects, just exactly what we're talking about today, with wonderful partners like Intel and delivering it through OROC. He's absolutely been focused on cybersecurity, and he was the lead and will continue as we move forward with this solution for hybrid cloud environments. And then we have Eric Van Arsdale, who's the VP for Federal Sales, part of OROC. He is managing the hardened security solution. Prior to joining OROC, he was a Navy cyber engineering manager for air and missile defense sector. He was at Johns Hopkins, as we like to call it, APL, the Applied Physics Lab. Did a lot of work there, and prior to that, he was part of Department of the Navy, cybersecurity lead for the Aegis shipbuilding program. So again, we've got three really experienced and great folks that are part of this. So thank you, Bill and Adam. And I'm going to share some slides, and I will let you all kick it off. And hopefully you're starting to see slides. You'll tell me if you are. All right.
Yeah, thank you, Gretchen.
Perfect. And I know I went fast, but again, we've got Bill, Adam, and Eric that are part of this. And I'm going to move forward and hopefully. Are you seeing the next slide, I hope?
No, I went back to your screen, but while you do that, let me just give a,
Sure.
Set some context while we get the slides going. So thank you, Gretchen. I appreciate it. Again, Bill Giard. So I lead our overall, product and solution architecture here at Intel in our data center group for our enterprise and government customers. I think it's no surprise to many that we're seeing just a rapid increase in security and attacks going in the environment, penetrating both hardware and software. And this is a partnership that we've started many years ago with Lockheed Martin, serving their federal high sensitive environments. And I think one of the exciting things that I'm super happy to review today really is the work that we're bringing to improve, security and quality of service and determinism to the market broadly, and most specifically, the offering that we're giving that to our customers for ready available solutions in, OROC, right? And so, with that, I think we'll kind of get going once we get the slides, fully available. But Eric, maybe you can chime in and just see, what are you hearing from your customers around the barriers for security in the cloud, and what's the opportunity that we're bringing together for our joint customers here on the roundtable today? Eric, I think you're on mute. There we go. There you go.
There we go. There's the double mute. Got me. So Eric Van Arsdal, OROC Technologies. So this is a great partnership coming together. As Gretchen talked about, I came out of Johns Hopkins Applied Physics Lab. Prior to that, I was with the Navy. And back when I was with the Navy, it was really about how do we increase the speed. We need to get our products to the market. And that's not just for the federal government, but for commercial. What are the problems with the cloud? Security, whenever we talk about security outside of the Fortune 100 or 500, security becomes a really big problem. When we talk about national security systems, when we talk about unclassified data that is really sensitive, people have a lot of angst when they go to the cloud. So with the partnership that we've created here, with what we're doing with Intel Hardened Security, we're going to talk about it and see, and hopefully show you guys that, or all of our customers, that we really have a revolutionary product that we want to talk to you about and show you that the next evolution of computing is here, and with that comes the security. So back to you guys.
Thank you, Eric. I mean, here on this slide, you're seeing just a number of attacks that I think, most in the audience are familiar with. But, just the breadth and depth in which they're, we're seeing those attacks and the attack surface changing, really, fundamentally addressing security at the start of the design to the solution implications becomes critically important. So with that, we'll go to the next slide, and we'll talk about, really, the approach. What's the innovation that we bring to market? The partnership that we've had, deep relationships with Intel and Lockheed Martin to improve security. But as Eric mentioned, security becomes the number one reason that organizations are hesitant to move to cloud environments. And it's not that we don't have secure solutions. It's just that it's a full stack deployment, and we think we've done something unique and innovative here. With respect to improving not only security, but performance and determinism. And this is, an effort that we've started many years ago. We announced it at our, Intel second generation Xeon Scalable launch, where, we've fundamentally improved not only the hardware capabilities in our hardware platform, bringing, new levels of security, for the time that the boots, the time turns on, but also bringing that forward into, software solutions, right? And so this is a product that's been in the market for our, missions work with Lockheed Martin for several years. And so it's been since our Broadwell days, and we made the decision to bring that more broadly to our customers on, Xeon Scalable second generation. And that brings capabilities that we've done from pure isolation from the time it boots, ships from the factory, from the OEM into, the cloud environment. And so I want to give this opportunity, to you, Adam, to just talk about, what it is, that we've done and where we've advanced some things pretty substantially with respect to end user solutions, and being able to do that from what was a, custom built, for very specific, missions work for the federal government through Lockheed Martin to, really broad available with partners like OROC.
Bill. Yeah, so our teams at the engineering level have been working together for the last 8 to 10 years, and more formally in the last 4 years, we figured out how to really partner and work together and bring more robust security and determinism, which is very important for many of our systems, to the high-end processing that Intel provides. So, at the executive level, we got executives from both Intel and Lockheed Martin together in late 2017 and formed an MOU. And ever since, our Lockheed Martin team has been an embedded team within Bill's team at Intel doing development work.
Yeah, it's been a pretty powerful partnership where we get really detailed discussion, not only product roadmap matrix tests, but how do we bring that to an end user solution. So let's, Gretchen, get into the details on what we've done and what we've brought available. So as we look at the security and the attack surface, it really is critically important to not only protect the applications as they're running, but really provide that foundational root of trust from the moment the system powers on. And so, what we've done, with Lockheed Martin really is, embedded security and isolation technologies, leveraging Intel hardware designed specifically to be able to, be broadly deployed, through our mainstream Xeon Scalable processors that not only protect, the system at the moment it turns on, uses technologies like, Intel Boot Guard to be able to protect the UEFI and the BIOS and ensure a trusted BIOS. And then we actually load, the secure runtime environment before we, allocate cores, threads, and memory, to virtual machines. And it really gives us unprecedented levels of determinism, security, and isolation from, the way that the system boots to the time it runs. And then, provide integrated and seamless security such that there's no attack points, through the boot process to the runtime flow to be able to give you, levels of security. And we'll talk about that isolation in more details on the next slide. But there's really 3 levels of protection. There's one where we isolate the resources themselves. That gives you, the ability to, share resources at some level. And then, middle level where we protect both the cores and the cache along with the memory allocation to do that, and then encrypt the memory through software, to be able to protect those, really protected environments. That gets hardware-based memory protection, our next generation that we're deeply involved with, the team in Lockheed to enable. But maybe we'll talk about that in the next flow. But the key message here is really taking a full system view, right? As you look at the attack surfaces, they're really designed to come in. There's 3 levels of attacks that predominantly impact enterprise and federal customers. One's pure, administrative access, right? Privileged access controls. That's where, making sure that we, covered the deployment, with partners like OROC and the way it's managed and configured. The second one is misconfiguration, right? You've left ports open, you left, various access controls open. And the third was software patching and provisioning, right? Really all intended to attack further down in the stack to the hardware. So ensuring, really software-based and hardware-based isolation between VMs, working with partners like Lockheed Martin and OROC to ensure the configuration is in fact managed and the privileged access controls are there. And we really feel very strongly that this joint offering that we're making available, in end user solutions pre-configured with experts in the industry really gives us unprecedented levels of performance, determinism, and security. And so diving down a little bit more in that, and critically important, so, traditional VMs and virtualized environments that you see in typical, cloud infrastructure, both on-premise or in mainstream environments, really share those, cores and threads, right? Virtualization grew up where we had a finite set of resources, 2 to 4 cores, and we wanted to over-provision and share those resources and then access them through a scheduler. That is how virtualization grew up. But as, Gretchen and other folks are trying to, the more advent that we get with, more cores, more memory, Moore's law continues to progress and delivering resources for end users, we have the ability to, fully allocate those resources and still get the benefits of software-defined infrastructure and manageability. So unlike traditional virtualization where you pull them all together and protect them, what we do here is we cryptographically isolate the resources at the moment the system turns on. So we allocate the cores and the threads fully towards individual virtual machine. And then we extend that to, allocated L3 cache, memory, and then I/O subsystems. And so what this gives you is fundamentally a bare metal-like performance, right, inside of a virtualized environment that gives you very high levels of performance, virtually from the operating system. It looks and feels like a bare metal machine. And so, improved total cost of ownership and security. But it gives you really a unique and innovative way to approach the security. And so one of the things that we demonstrated early in this year is really the levels of protection that you can get for forward leading of attacks. And one of the challenges really is not only providing a generational stepping stone to preventing new forward attacks, but also be able to handle new forms of attacks that allow organizations to keep ahead of the patching and provisioning pain points that you have in the environment. And so really it is an exciting approach to be able to bring this level of security and determinism broadly through commercial offerings with partners like OROC. So you want to go to the next slide?
Yeah.
So let's talk about how we're bringing that forward and what we have available for our customers on the call.
All right, so Eric Van Arsdal here. Gretchen, looks like it's my turn. So thank you. First and foremost, the partnership with Intel and Lockheed is really opening up a lot of capabilities within the marketplace, especially with cloud computing and where our customers want to go. So we're really excited about this partnership and where we think we can take virtualization technology, or commonly referred to today as the cloud. So why OROC? Next slide, please. So we'll run through this real quick. Then I really want to get into that SDP, that security determinism performance. And Bill was just talking about a lot of that security piece. But, first, OROC was founded, and why are we the partner of choice with Intel and Lockheed on this? Is we were founded with security as a foundation. We're the first and only OpenStack FedRAMP authorized cloud with up to 422 controls in our high. And then you get to, you have full control over that as the customer. So through our partnerships, next slide, please. So through our partnerships, we fully expect to be completely disruptive to the market. So that's the cloud technology market. Through security performance determinism, we also bring the compliance piece. We bring the cost predictability piece. Bill was talking about bare metal. We're going to get into that a little bit. We want our customers to have full control of their data. That's something that goes into vendor lock-in. So through our encryption and the really cool stuff that Lockheed developed in partnership with Intel, bringing in OROC, we really want to liberate the data and allow our customers to use it. This slide really is where I want to open it up a little bit to the panel, or to Bill and Adam, is we talked a lot about security. What does that really mean when it comes to the OROC cloud and what we can deliver to our customers? To me, security has always been the critical piece of going to the cloud. There's other reasons, and I know we have the poll question we'll open up in a little while, but what we've created as partnership and delivering through the cloud now is that true determinism based on your mission critical application. We need to get into that and understand what does that mean. So mission critical to your business, or we're even looking at real-time operating systems at the edge. That goes into the performance. Before IHS, this type of capability didn't exist in any cloud platform. You can get determinism without the performance. You can overbuy in order to get your performance or more predictability, but you couldn't get security determinism and performance all in the same cloud, on the same platform. The only way you could get this before is actually through bare metal in the cloud, or keep your on-stack on-prem stack. So, Adam, Bill, anything that you would like to add to this, or we can go on to the next slide and then get into the panel discussion.
I can go ahead and add some context. I mean, I think you're exactly right, Eric. I mean, one of the key challenges, for any enterprise and federal customer really is, balancing dedicated hardware, right? A dedicated server to be able to ensure that you either have the right configuration and isolation, right, to be able to protect those sensitive assets. So what we typically see, and Intel's no exception, is our high sensitive environments have traditionally been on dedicated hardware, or in the cloud environment, dedicated instances with additional protection controls to isolate them. That ends up being, very expensive, right? It ends up being, less responsive from an agility and time of provisioning. But what we've seen, with this technology is the ability to take advantage of some of the more advanced AI algorithms that tend to consume lots of CPU cycles. So we have one customer that has uses technology that we can share a solution brief on that essentially has 3 secure VM domains that allow you to ingest data, right, from an edge perspective, right, video and image capture in one domain with full core allocation, like it was its own dedicated hard piece of hardware. But in the same CPU and socket, be able to run full inferencing with Intel deep learning and DL Boost to be able to do image and video inferencing algorithms, and then use the third domain to be able to do high volume transaction for security and video surveillance. But those are just use case examples that highlight the ability to be able to run environments that were traditionally their own dedicated bare metal server, separate in the instance, in an environment. But as you point out, security and audit, and your previous slide is very powerful with respect to, as we look at what our customers are struggling with, the ability to assert and attest, right, and be able to meet audit and regulatory compliance, to meet the other elements of high vulnerability for misconfiguration, privileged access management, be able to certify that your protection. And one of the challenges that we've seen, especially in the federal space, is to be able to actually meet those controls while taking advantage of agile, responsive infrastructure, right, as services change. And so that, partnership to be able to bring, deep hardware and software optimization for security, performance, and determinism into, an environment that's managed and configured by experts like OROC becomes critically important.
Agree.
Yeah, I think you hit the nail on the head. We've been trying to come up with a way to say this at a less technical term, and we were talking about time slicing, and we're getting into core division, and we're going to get into that in that panel discussion, so I don't want to go there quite yet. But great words. I think you hit the nail on the head. So instead of what do we offer as far as OROC technologies in our cloud, right, is one of the big differentiators with us beyond just IHS is that we have a true hybrid cloud. That means one API. It means it's the exact same look, feel on-prem as in our cloud. Now, a lot of my customers are looking at that 20-30% on-prem and still 70-80 model. So depending on what your IT strategy is, but because we've talked about those mission critical applications or workloads or that sensitive data, they're really hesitant to go away from that on-premise piece. So with OROC, you get a true hybrid cloud. We can deliver that through the cloud, through our hybrid on-prem, and actually to the edge, all with IHS. So that means that we can run real-time operating systems at the edge, et cetera. And we'll get into more about the delivery methodology at the end. But basically, the way OROC has turned this into a product is that it's just an additional option whenever you come by our cloud. So what we want to do is we want to work with our customers. We want that seat at the table to show you that we really know what we're talking about, and we can help you as an organization come into or transition to the cloud practice. So this is either expanding or adopting cloud technology practices. So, Gretchen?
Perfect. Well, thank you. I think that does a great job in terms of setting the stage. So we talked about this, and we have a polling question. So Abby and the team from from our organization that's helping us put this together is going to put out a polling question to everybody. And it specifically is, what's keeping you today from expanding or adopting any kind of a cloud practice? And security, predictability, performance, cost, and control are the kinds of questions that, or I should say answers that we're curious to see. So as the poll question is going up, what I'm going to do is start with a couple questions we have, and then we're already starting to get some questions from folks that are on the line, which is really terrific. So thank you. So again, Adam and Bill and Eric, thanks for setting the stage. And as I had mentioned, I'm always all about the data, and it's really important that it's incredibly secure. And as our customers and as I think it was Bill who mentioned, people are trying to do inferencing at the edge, they're trying to do training at the edge, but how do you ensure that that data is secure? And this solution is absolutely one of them. So as we think about that, and I'll open this up to any one of you, but as your organization, that critical information is absolutely a strategic asset. So what are the key concerns that you all have seen from a security perspective, and why that really jump-started this partnership and the creation of this hardened security solution?
Well, I can start. I'm not shy when it comes to responding. So I think, first and foremost, what we're seeing is attacks. It used to be perimeter-based controls, firewalling, right? Isolation of a piece of hardware was sufficient in a lot of the attacks. And what we've seen, as an industry, really is the level of sophistication and the actors those that are actually funding those attacks have increased rapidly. And they're all designed to be able to, number one, go down from entry points deeper into the hardware, right? So they go, essentially deep into the hardware, and then they try to go east and west within the data center, right? From one VM to the next, from one server to the next, through the network. And so ensuring that we're doing both hardware and software-based protection controls was critical, right? That's why we started on this effort, many years ago. And we're very public around the capability we brought together, with Lockheed and our partners. But the second one, and I see a question on 5G that become really apparent, really is as edge computing progresses, right? Not only did we have to do more to address foundational, security within the server and within the computing environment within the data center, but those perimeter-based controls just don't exist. Not only are they necessary but insufficient in the traditional data center, but those traditional compensating controls don't exist at the edge. And as data grows, as the need to actually process and synthesize that data before you actually transmit over the network becomes more important. Edge computing drove the need for improved physical security, right? We saw that in insider threats within the federal space, post Snowden era on, how do we actually do more controls for things that may have physical access in the data center. But that's clearly more important, even more important at the edge as you have a distributed computing environment and you connect it to your data center such that you don't have the traditional HVAC controls that have an entry point to, suck data out, right? And so you have to protect all of the security components in a distributed computing environment in a way that's integrated and seamless.
Adam, anything to add before I jump in?
No, I agree. So a lot of, so Eric, when you showed performance, security, and determinism, again, performance is why we did a big migration years ago to Intel processors because they're the best performing processors. But we needed determinism and security at the same time. So that drove us to look at the computing system much differently than what the commercial world did at the same time for the direct needs of much of our equipment that is at the edge. For multi-core processors, we needed it. We couldn't just have performance. We needed security and determinism.
Perfect. So while I wasn't there whenever you guys partnered and started creating this, I was actually at the Navy and working a lot of the same problems. So when it came to security, but fast forward real quick is I'm at OROC Technologies, and security in the cloud. And what we keep talking about is what's the next evolution? What's the new thing that's going to drive our customers to adopt or expand their cloud technology practices? For me, it's really about the great work and the engineering that's gone into this for a key reason that the traditional commercial customers and hyperscalers just don't have a reason to solve this problem, in my opinion. But where you go with that is you take security into a multi-tenant environment, and it's at the most basic layer. And I know we talked about this, but it's your security perimeter is shared with other companies. It's a time slice, right? So that's where we talked about that shared resources with the cache. Until now, you couldn't break that off from the core processing. With this technology, we're doing that. So for me, it's why would you solve this problem? It's what is your mission critical application, and what is the impact, meaning a cost impact to your business. So the second part to me is what is the cost impact to your business by not adopting cloud technology, and that access and the speed of relevance and being able to adopt 5G or adopt new technologies faster. You know, from my background, I think about nation state 5 and 6 actors and staying ahead of the game. And through the delivery of OROC with the great engineering that Lockheed and Intel have provided and will continue to develop, I just believe that this is truly a game-changing technology. Gretchen?
Yeah, and when you think about those three, I'll call it the three-legged stool, thinking about security and performance and determinism, one of the questions that has been asked, and it honestly was one that I was going to ask in case we didn't get any questions, is, you know, how do you balance that, and what are the ways, especially as you start to think about 5G and new technologies, that this solution will allow that adoption to happen faster?
Yeah, I mean, it's traditionally been a balance from, you know, when you encrypt everything and have to do that at runtime. And so one of the things that, you know, the earlier slides talked about was the fact that, you know, the balance now becomes a capacity, right, versus a performance trade-off, right? I mean, there are additional things that we fully allocate, you know, the cores within a system and the threads, and then the cacheways, as Eric points out, to be able to ensure very deterministic, high levels of real-time performance, even at very, very high load. And so, you know, in addition to that we don't always talk about at great depth, but, you know, there's also additional technology that we leverage from Lockheed that allows us to monitor and detect certain levels of attacks. And we actually allocate, you know, one of the cores fully in the system to be able to go manage and provision that, you know, fully isolate it before it comes up. So you're not taking the performance at runtime of allocation. And so the balance now is not a performance versus security trade-off, right? We've changed it with Moore's law to be able to do a balance of capacity, right? And so we have very, you know, high levels number of cores and CPUs and higher level SKUs that allow us to manage that capacity and then bring that available to them, you know, in your cloud environment, that you're still paying for that VM, but, you know, the end user through OROC isn't, you know, managing that capacity, right? That is something that experts like our cloud service providers can do for them. So the great news is in that deployment that we're highlighting today, that capacity is one that Intel has worked with OROC to be able to help, you know, pre-manage the capacity, but the end user doesn't have to make that trade-off at the time. Do I want a secure instance or do I want a deterministic instance? They can actually get that already done, and the infrastructure is already supporting it. And that is very applicable when you talk about deploying that to, you know, 5G, right, to base stations, to be able to understand, you know, how do I bring computing to the edge where I want to, you know, I referenced one edge example where you had data ingestion, right, that has allocated cores, and you have to make sure you capture all of the image and video. And then you want to run full capacity on your inferencing engine and take advantage of Intel AI technologies in the Xeon, right, you know, so that you can get the performance that Adam was mentioning around on our multi-core, and then be able to actually transmit that and synthesize. So that translates, you know, really from changing the trade-off conversation from a, you know, do I want performance or determinism or security, to, hey, how do I get those in the right, you know, capacity? So it's moved the conversation a bit.
And I'll give Adam a quick second in case I don't want to jump on you every time here, but
No, I
otherwise
agree.
I'll jump in here. Okay, so taking that through like a stool. So as I mentioned earlier, with 5G, that's going to be a next revolution. Especially with edge computing, real-time operating systems, really postulate what you think we can do with virtualization or cloud technology. Now, if we've really helped solve that security piece, or at least mitigated a lot of those risks, we get into, we want to make sure you're getting what you're paying for. And one of my analogies, and a partner of mine here at OROC really helped bring this to fruition is, we're talking about time division CPU access versus and core division CPU access. So under time division, if you look back at the telcos many years ago, we believe that this is as good of or the next evolution of computing, the same way TDMA to CDMA was with your telcos. So you're no longer having to pay for every minute and over allocating everything within a typical hyperscaler. So kind of like buying an airline ticket with, they over allocate, you get there and you can't get on the airline because you don't have a seat. So you're waiting for that next plane. Going to the new CDMA or CDCA, core division CPU access. It's a new thing that we're trying to flesh out here. But now you get just your piece of the pie. You don't buy the whole pie. You get your piece of the pie at a very rudimentary level, right? So this is the competition. It's like, I only want this piece. I want absolute determinism, security, and performance, but I only want this piece of the pie, and I want to make sure it absolutely works. That is the only way you ever get to a cloud whenever you talk about mission-critical technologies at the edge or just purely mission-critical or business-sensitive things that absolutely have to happen at the same time every single time. And I go back to whenever I think about that determinism or the performance was whenever I was shooting the 5-inch gun on a DDG is I have to absolutely know where that bullet leaves that barrel when it's traveling 20 or 30 miles in a C state of 3 or whatever, right? Because you absolutely need to know, and we can bring that to the cloud or through the cloud now. Adam, anything else to add, or Bill?
I think you covered it. Yeah. Do you have another question, Gretchen?
I do. There's a number that have come up, and I think one of them I'm liking in terms of when we think about, one of our customers, for instance, is really looking at leveraging SIPR, NIPR, JWICS kind of networks and doing that in, a server, and they can partition the core, the memory, even the peripherals like a NIC card. So literally you could have those 3 networks being run. And one of the questions here is saying, when you're thinking about the end user or that device, how would you do that security authentication? So you think about, maybe SIPR, NIPR, JWICS, and different people have different access. So how do you ensure that you have that authentication when you're running in this kind of environment? I didn't mean to stump anybody.
No, I just didn't want to jump in before Eric or Adam. Like I'm always quick to jump in. You want me to take that one? Okay, so
Yeah,
I think our authentication and isolation, right? Especially when you're running different protocols, becomes very important. So one of the things that we've done, really is depending on the network protocol interface that's running into a VM, is having those dedicated, hardware, NICs and network, allocated to the VM, such that you're not sharing, some of those, and you're actually getting a shared vulnerability between those network ports to the virtual machine or to the secure domain, right? And so, our approach there really is fundamentally allocating at the PCIe level those IDs, straight to that, so that network interface is only allocated and available through that secure domain. And so it gives you both flexibility of not having to write custom network, protection controls, or what I would describe as compensating security controls for shared resources into, really cryptographically isolating both the attached network device to, the secure runtime environment. And so that really is our approach. And it translates a bit further into the fact that we're, we don't spend enough time describing the fact that, the need to, code for new architectures is very problematic for a lot of customers. And, we support that and some modern security things like what we're doing for SGX. But that's a big, software enabling uplift, right? Especially when you're uplifting from an on-premise to a cloud environment. And so, the architecture here gives you actually, we talk about determinism, but allows you to run, traditional, the legacy Linux environments or other flows in there without having to rewrite your application and be able to move that into secure things with secure network components. And that's because, we actually isolate that, and I mentioned the capacity at the time of allocation, so that once you get it, you access it like you would have normal resources without going through additional security protocol. So we handle that for the end user at the time that they're getting the system in deployment, and that happens kind of consistently throughout.
Yeah. And when you're delivering this is a question for you, Eric, when this is being delivered to our customers, is this something that you would deliver on-prem? Is it something that you would deliver in a cloud? I mean, how is this, going to be delivered by OROC to a customer?
So, great question. And first and foremost, everything we build in the cloud is an exact replica whenever we deliver it on-prem. Then you take the edge computing devices. So all of the security we deliver to the edge or to on-prem. It's through the partnerships. When it comes into the classified, we work with strategic partners to make sure everything's delivered. So I can't really get into that because it depends on what partner you're asking us to work with and how to work with individual customers, because go back to the very beginning of this is absolute control. I want our customers to have, or we want our customers to have control of data through end-to-end encryption, through the dark fiber that we control, all the different things that make OROC unique through the OpenStack and open source. So this is one of those that I would actually ask for people or our customers, come talk to us. Let's really show you how we do this and deliver the right solution for you.
Terrific. And one of the things is, I know we're talking about determinism, which is predictability. So if you're a statistician, everything's about predictability. But why does this matter in a cloud, and why is this important for this solution? And anybody can jump in.
So if you're no, go ahead.
Go ahead, Adam.
Well, so there's several applications. Whenever you have to have control of something, it has to work the same way every time. I guess there's some analytics problems where determinism is not important, as important when you're trying to figure out sort of a solution. But if you're in a real-time system, that has to work the same. There can't be any ambiguity that many of us have, like when you start a laptop or anything like that. It has to work exactly the same every time. So more than predictable, it's a safety issue. It's a mission-critical issue. But from a convenience standpoint, we found in one of our test beds was that when engineers were doing even analytics, the fact that their run times of fairly complex simulations and computations ran the same amount of time for the same size problem every time. And that was a quality of service that they hadn't experienced using, other computing devices. And so that was unexpected. We thought, we keep thinking about mission critical systems, and that's most important. But even from a planning of your day and your time, because of analytical workloads, what was, quality of work for individuals was value added. Yeah,
absolutely a great explanation there. And actually working with Adam's team, one of the things is the predictability, the determinism, performance. I'm going to lump those in kind of together on this one. Is think about the robots and that were sixed off, and we're showing a machine controller demo next week that really shows that I can run a robot through a cloud technology or a cloud that previously it was either bare metal or you had your own server that's over allocated to make sure that robot does exactly the same thing every single time at that exact moment. You either bring in safety concerns, you bring in a lot of different things that just wasn't available or a capability of utilizing a cloud technology before. You know, when you have those shared resources, you absolutely cannot do that. So I love that question, and we're really excited about showing what we really can do with this through demonstrations and et cetera.
Do you have any more that you want to add, Bill? Because I'd love to jump into, you had mentioned coding and that, you know, we're talking about open source and the need to have to continue to code and recode as folks are developing work within the cloud, and that workloads that they're moving to the cloud. And the idea is you don't have to make changes if you're leveraging this solution. So I'd love you or Adam or Eric to really talk about the need for, hey, whether it's on-prem or in the cloud, it will run. We're really talking about a different level of sophistication that isn't going to cause every coder to have to continue to make changes.
Yeah, so I'm a firm believer of defense in depth, right? And so, you know, I think, you know, secure coding practices and, you know, continuous, you know, uplift and keeping on and engaging the application teams is critically important. In fact, in my previous role at Intel, I was responsible for, you know, the secure, you know, coding and software infrastructure for enterprise environment. And we run through their own set of static and dynamic code analysis. And so I'm, you know, I always recommend to a customer that they continue to manage the code that they can deploy. But that is a tough, you know, hamster wheel of continuing to keep up on the advanced separate tech. So that should continue, necessary but insufficient, right? And so, you know, what we've done here is be able to mitigate the vulnerabilities that you may have from one application to the next based off the fact that they can penetrate further into the hardware. And so what we recognize that you need a defense in depth strategy. You need perimeter controls, you need application secure practices, you need good practices for configuration management, and you need, you know, fundamentally good hardware, right? And security in terms of hardware that allows you to continue to isolate and create, you know, what I would describe as a, you know, virtual firewall, you know, within the socket, right? Protecting cache, protecting cores, protecting memory, you know, such that it can run. And so this is, you know, a fundamental, you know, game changer, you know, for me as an IT administrator on how do I keep up on, you know, the continuous patching that I must do with respect to, you know, operating systems, you know, the continuous integration for, you know, continuous, you know, static code analysis as new vulnerabilities are defined. How can I put additional controls in there as I'm continuing to ramp up that, right? And it's very difficult as an IT organization, right? We have, you know, over 300,000 servers at Intel. We have, you know, 3,000 plus applications. That just maintenance and operations, right, become you know, difficult, right, just from a time to deploy. And that's why partnering with OROC that helps manage that infrastructure deployment and patching and provisioning, configuration management with advanced, you know, forward-leading, you know, security controls that can add, you know, additional mitigation, right, and protection against those advanced attacks in the time that you have to coordinate in a typical, you know, data center environment or cloud environment where your neighbor may not be as diligent as you are. And so, you know, not having those risks and addressing those barriers to working in a shared multi-tenant environment or cloud environment becomes, you know, super important and super encouraging from, you know, the trust and the ability to be able to execute at that pace that you need to.
I'll jump in. Great. So that's, I don't know that I can top that, but with OROC Technologies, the value delivery through the on-prem deployment through our hybrid cloud. And I just want to mention even the Government Innovation Award that we just won with Army on the CI/CD, because what we really want to do is we want to, as my chief solution architect and I always talk about, is we want to drive people or organizations to spend more time on the people creating better coding and better practices, better processes than doing some of that actual work themselves. So having that access and having that pipeline, and that really goes into DevSecOps and that continuous model. You talked about defensive depth. I absolutely love that word. We used it because it's all those layers of security in order to get to the end game. It's the only way you stay ahead of the adversaries. And the only way you can really do that, especially if you're not that Fortune 100, 500 that really has those resources, is, years ago I thought go to the cloud because those guys are really partnering with the right people to keep up with security and keep driving and pushing those capabilities down to you. And that's where I really get into that 20 and 30 or 20 to 30% and then 70, 80% in the cloud is that, I really see that as the value delivery in order to enable those people to do better coding and better security, and they don't need to worry about some of this IT infrastructure because they can really put those resources in the right place. Back to you, Gretchen.
And any additional comments from you, Adam?
No, I think they covered it well. Thank you.
All right, cool. Well, yeah, and I think a lot of people think of security as software only, and really what all of you have talked about and what the solution is the marriage of hardware and software. There are some things that we can easily mitigate, and to help them from an IT perspective, as you said, focus much more on better coding, better development, better running of their infrastructure. But I'm curious, as we're almost wrapping up, we've got just about 5 minutes left. Are there other things that we have not mentioned or I'll call them future advancements that you'll see in next generation hardware and secure infrastructure and hardened security solutions that we'll see as we move forward, whether it be 5G connectivity or beyond?
Yeah, I mean, I mentioned that, this was on our second generation, right? Our new upcoming launch, we're adding, additional security controls and capabilities for, remote provisioning and taking advantage of when SGX, becomes part of our mainstream, right? Those are software, secure technologies that we can use to, we're further enhancing the work we're doing with Lockheed very closely with Adam and his team on the product that we're shipping with Ice Lake. We add essentially multi-tenant hardware-based memory protection, right, kind of throughout the stack, right? It extends beyond what we've just done with our Xeon Scalable to our, lower power, high vibration environments with our D product line. And so we're quite excited by, I mentioned, this is, it's not a first generation. It was actually a second generation product that we made broadly available. That's, shipping and running in production, at Lockheed, that's now available broadly on our general purpose. And that roadmap continues to get better, right? As we understand the application and making those available in, our upcoming Ice Lake, our new, product flow. And so there's lots of work that we're doing in there with respect to security and performance, while advancing our AI algorithms, right, and our network, and what we're doing for crypto acceleration, and what we're doing for the advancement of larger memory pools and new AI instruction sets to be able to continue to enhance that. And so it's definitely one that we're excited about continuing to bring that capability. And Lockheed's been a fantastic partner among others that we have kind of broadly that really gives us a very in-depth usage model conversation, real-world workloads that we're actually trying and improving that meets both their own internal mission work, but also their willingness to bring that and help the industry as a whole improve the overall capability offerings, like what we're doing with our rocks. And so it's a good, healthy roadmap discussion for how are we continuing to stay ahead of what's happening in the environment in a way that is fast moving, and in a way that we need to deploy at the edge, we need to deploy in data centers on the flow. So I'll let Adam and Eric talk more, but I'm personally super excited about the new improvements that we're doing and we're continuing to do. Super excited about what we have today because it's immediately available and it's tried and true, and continue to move forward with that.
Just to add on to what Bill said, so our two teams bring experience at different problem sets, but then we focus them on the same capability that is useful in a wide range of uses. So kind of the synergy of the multiple use cases and applying them to ever increasing capable components from Intel. I see that as this is just the beginning.
And I'll jump on, take it to the cloud side. Is one, I'm absolutely ecstatic about the partnership here with Lockheed and Intel. I keep going back to the engineering and what you guys are doing, but the roadmap between the three of us, the differences that we're bringing together, and reminding everybody that this is actually being delivered as a COTS product, that's pretty revolutionary. Where we're going with 5G. Not to mention that you've never seen this in a cloud before. We're excited about that. It's about getting the message out there and showing our customers what we can do. And then as we get into the edge computing, and this really is a game-changing technology and helping shape the IT strategy of the future. And I'll turn it back over to you, Gretchen.
Terrific. Well, I think we are just at about time. So I really want to say thank you, Adam and William and Eric, for the partnership. It is, I kind of came late to the game in terms of working with Bill and Adam and the team, but it is a really innovative solution. And as somebody who spends a lot of time digging into data and trying to figure out how we can remove latencies and not have delays and leverage persistent memory and just other things that we have available, this is just a spot-on solution to really help our customers, not only federal, but enterprise customers. Selfishly, being public sector, we care about our government customers, but it's absolutely a great solution for those who are in the enterprise also. So again, thank you all so very much. I really appreciate it. And with that, I'm going to say thanks so much. And any of the questions that we didn't answer, we will absolutely answer those, and those will be available along with the repeat in the next few days. So again, thank you everybody for joining, and have a great afternoon.